What if I told you NASA's most powerful planet-hunting telescope is launching soon, and most people don't even know it exists? This isn't a sequel to the James Webb. It's something different, wider, smarter, riskier. And it was almost cancelled. They call it the Nancy Grace Roman Space Telescope, but its mission is anything but graceful. It's designed to find invisible planets, reveal dark energy's secrets, and take snapshots of the entire universe faster than anything before it. While JWST zooms in like a sniper, Roman sweeps the cosmos like a satellite drone, catching what others miss. In 26, this telescope could rewrite everything we think we know about space. This is Dominion Hour, and you're about to discover NASA's secret weapon in the cosmic race. So what is this mysterious telescope? Officially named the Nancy Grace Roman Space Telescope, it honors NASA's first chief of astronomy. She was a visionary who championed space telescopes before Hubble even launched. Roman's design is radically wide-field, like giving Hubble panoramic vision. It can scan areas of the sky 100 times larger than Hubble in stunning detail. Think of it as the wide-angle eye of NASA. Its key instruments include the Wide Field Instrument for galaxy surveys and a groundbreaking coronagraph for imaging exoplanets. Unlike JWST, which focuses on deep cosmic time, Roman's job is to map vast areas of the universe to spot what hides in the big picture. It's like comparing a microscope to a drone. And when it launches in 2026, it could become the most important observatory of this decade, if it succeeds. Let's clear something up. The Nancy Grace Roman Space Telescope is not a backup for the James Webb. It's not even trying to do the same job. JWST is built to stare deep into time, at one galaxy, one nebula, one ancient star system. Roman? It plays a different game. It scans millions of galaxies at once. Roman's wide field of view makes it the mapmaker, while Webb is the microscope. Webb zooms in on cosmic fossils. Roman looks for cosmic patterns, the structure of the universe itself. And they work together. Roman will show scientists where to look, and JWST will zoom in for answers. With this tag team, NASA finally has the tools to study not just what's out there, but why it's there. Roman isn't replacing Webb, it's completing the story. Here's what most people don't know. The Roman Space Telescope was almost cancelled. Back in the early 2010s, NASA was juggling missions. Roman, then called JWST, was considered too expensive and not urgent. The project was quietly shelved. But behind the scenes, scientists were fighting back. They knew this telescope could unlock answers about dark energy, rogue planets, and the fate of the universe. Then something incredible happened. NASA was offered a spare classified spy satellite, its mirror nearly identical to Hubble's. That one gift slashed Roman's cost and doubled its potential. The project was reborn, renamed for Nancy Grace Roman herself, and greenlit. What we almost lost could now be the telescope that maps the cosmic web, finds thousands of new worlds, and rewrites physics as we know it. Sometimes the best missions are the ones that almost didn't happen. Roman's first major mission? Solve one of the biggest mysteries in all of physics: dark energy. Right now, we know the universe is expanding, but not just expanding, accelerating. And we don't know why. Dark energy is the name we gave to this unknown force, but it makes up nearly 70% of the universe. Roman will observe distant supernovae, measure the shapes of galaxies, and track how matter has moved over billions of years, like a 3D time-lapse of the universe. The goal? To map how dark energy has affected space over time. If Roman finds the expansion is changing, it could mean dark energy isn't constant, and that changes everything we thought we knew about gravity and the fate of the cosmos. Some telescopes take pictures. Roman might predict the end of the universe. Roman won't just study galaxies, it's going planet hunting, but not the way JWST does. Roman uses a rare trick called gravitational microlensing, and it might reveal the most Earth-like planets we've ever found. Here's how it works. When a planet passes in front of a distant star, its gravity bends and magnifies the light behind it. Roman can spot this lensing effect, even if the planet itself is dark, frozen, or wandering through space alone. That means Roman could discover rogue planets, untethered to stars, or worlds smaller than Earth, farther from their suns than anything we've ever seen. It won't just detect planets, it'll detect the invisible ones, the ones no telescope has ever caught. If there's life on quiet, cold worlds out there, Roman might not just find them, it might map where to look next. Roman's power isn't just in what it finds, it's in what it sees all at once. Its wide-field instrument can photograph a patch of sky 100 times larger than Hubble ever could, and in stunning infrared detail. Imagine seeing an entire galaxy cluster, not as a dot, but as a living, glowing city of stars. This is where Roman shines. It doesn't just take snapshots. It captures the structure of the universe itself. Astronomers call it a survey telescope, a way to chart billions of galaxies and watch how they move, grow, and cluster. With each image, Roman builds a cosmic map, a time machine, a story written in light. And the wider it sees, the more likely it is to catch the rarest, weirdest, most unexpected objects we've ever seen. This is how you find what no one thought to look for. At the heart of Roman lies something extraordinary, a 300-megapixel camera with unmatched clarity. It's called the Wide Field Instrument, and it captures images in infrared, allowing Roman to peer through cosmic dust and see deeper into space than any wide-field telescope before it. But Roman isn't stopping there. It's also testing something never flown in space, a coronagraph, a revolutionary device that blocks a star's blinding light so we can directly photograph the planets orbiting around it. This tech could let us see exoplanets that were once invisible and study their atmospheres, orbits, even their colors. The coronagraph is experimental. It may not work perfectly, but if it does, it will lay the foundation for future missions that directly search for life. Roman isn't just built for science. It's a proving ground for the next generation of space telescopes. Roman's mission isn't just about space. It's about people. Thousands of them, working together across the globe. Over 2,600 scientists, engineers, and mission planners from 15 countries are collaborating to make the Roman Space Telescope a success. From observatories in Japan to control rooms in California, this mission is powered by human curiosity. Every pixel Roman captures is built from teamwork, data sharing, and decades of preparation. And it's not just NASA. The European Space Agency is helping too. Even NASA's upcoming Roman cousin, the Nancy Grace Roman Ground Support, is being designed to enhance what we learn. This kind of collaboration shows what humanity can do when we reach for something bigger than ourselves. Roman isn't just a telescope, it's a global science movement, because mapping the universe and understanding what it means is a mission too big for one nation alone. Roman isn't just chasing galaxies, it's chasing the force that's pushing the universe apart, dark energy. Here's the mystery. Galaxies aren't just drifting away from each other, they're speeding up. Something is accelerating the universe. And Roman might tell us what. It will use multiple methods to track the shape and growth of the cosmos, observing distant supernovae, mapping galaxy clusters, and measuring the subtle warps in space itself. If dark energy is constant, the universe keeps expanding. But if it changes, everything we thought about the future, gravity, space, time, might change too. Roman isn't solving a problem. It's confronting the biggest question in physics today. What is the fate of the universe? And it's doing it by scanning the sky frame by frame, like a cosmic detective, looking for the patterns that only a wide-field eye can see. Roman's mission isn't just science, it's wonder. Think about it. A telescope 1.5 million kilometers from Earth, watching stars explode, galaxies twist, and space itself stretch over billions of years. It's capturing light that left its source before our planet even formed. That light traveled for eons, only to land perfectly on Roman's mirror. This is why we explore. To witness things so vast they change the way we think about time, distance, and even life. With each survey, Roman paints a cosmic mural and reveals that we're part of a much bigger story. Yes, it's about dark energy. Yes, it's about exoplanets. But at its core, it's about perspective. Because when you see how small we are and how big the universe really is, you realize that discovery isn't about answers, it's about awe. Roman isn't just a telescope, it's a doorway for the next generation. Because when kids see the stars mapped by Roman, they don't just see galaxies, they see possibilities, futures, careers, questions worth asking. This mission is already inspiring young astronomers, engineers, and dreamers across the globe. Some will grow up and build what comes after Roman. This is how space science works. One generation builds the tools, the next generation asks the questions those tools unlock. With every discovery Roman makes, it sends a signal that curiosity matters, that we're allowed to wonder. The Nancy Grace Roman Space Telescope is named after a woman who saw what space telescopes could become, long before anyone believed her. Now, her name is etched into a machine that could change everything, and that story is already changing someone else's future. Roman is almost ready. But here's what most people don't know. It's launching soon, and barely anyone's talking about it. In 2026, NASA will send the Roman Space Telescope 1 million miles from Earth. But there's no fanfare, no national headlines, just quiet, careful progress. This telescope could map dark energy, find thousands of exoplanets, chart the cosmic web. And yet, it's not trending. Maybe that's because Roman isn't built to dazzle. It's built to discover, to do the slow, data-heavy work that leads to breakthroughs. But the scientists know, the dreamers know, and soon the world will know, because when Roman starts sending back its first images, when we see the universe in a way we've never seen it before, it won't be quiet anymore. It'll be the start of something big. The Roman Space Telescope is almost here, and its potential isn't just scientific, it's cinematic. Imagine the first images, glowing arcs from gravitational lensing, nebulae stitched together into massive mosaics, maybe even the silhouette of a planet orbiting its star. Roman will show us space in a way we've never seen, huge, detailed, alive. And when those images drop, just like Hubble did in the 90s, just like Webb did in 22, they'll flood social media, headline the news, and spark wonder in millions. Because beauty matters. Roman's job is science, but its impact is emotional. The same way astronauts looking back at Earth felt something shift, Roman could shift our place in the universe. Not just more data, more perspective. This is just the beginning. The Nancy Grace Roman Space Telescope launches soon, and when it does, it will change what we see and how we see it. From rogue planets to dark energy, from cosmic webs to gravitational arcs, Roman will turn invisible forces into vivid images. And when that first photo is released, when the first piece of data drops, the world will finally wake up to what's coming. Because Roman won't just find answers, It'll reveal new questions we never thought to ask. If you've watched this far, thank you. Subscribe to Dominion Hour for more stories about the future of space, science, and the search for meaning in the cosmos. And if Roman makes you feel small, inspired, or curious, share this video, because that's how exploration works, one light year at a time, together.